Okay, let us write down the mechanism for the following reaction. So you have been given one reactant and you have been given product. So let us see what are the changes that is taking place. You can decide the changes and then you can write down the mechanism. It's easy. So first you look the changes. Again, medium is acidic. So you have to write down the mechanism in acidic medium. So medium is again acidic. Getting it? So this is a acidic medium. So you see what are the changes that is taking place. You see here you have OH and this OH is gone. It looks like this OH is gone and from here H plus is gone. So it looks like this is a removal of H2O. So reaction looks like the removal of H2O. Are you getting around? So this is removal of H2O simply minus H2O. So this looks like this kind of reaction. So you have to write down the mechanism. So what can you do? You can protonate this oxygen and then make H plus, lose H2O, make carbocation. You cannot protonate this oxygen because if you protonate this and lose H2O, the carbocation found is a positive charge on the sp2 carbon that is not getting very stable, and this is a tertiary carbocation, so this is slightly stable. So it's better to form a carbocation here rather than at this position. Are you getting or not? So let us form a carbocation here. So if you have something like this, so initially you have this, and this is the reactant. Here you have one methyl group attached, here you have one OH attached, and then you have one benzene ring here, and then you have a double bond, and on this carbon you have this OH. Are you getting or not? Now what you have to do is you have H plus and this OH lone pair attacks on this H plus. So if you do this, you will have simple this. So you will have this, and then you will have a OH is attached here, and basically lone pair of OH I will use in the next step, and you will have this, and then if you attach OH plus H plus, then you will have H2O plus. So you will have this, and here you have H2O plus, OH2 plus. Now the next step you can lose basically H2O, and then you will have a positive charge on this carbon. Let me show the same step in one step. So this oxygen also attacks. Basically you will get the carbocation. If you want, you can show the two steps. So let me show in the two steps. So what I can do is I can show this in the two steps. So if I lose H2, I will get a carbocation, and this carbocation is basically a tertiary carbocation. So I will have this. So you will have a tertiary carbocation. Here you have, and then you have plus charge, and this carbocation is tertiary in nature, and you have oxygen. This oxygen contains two lone pair, and now this carbocation is basically 3-degree carbocation, and 3-degree carbocation is generally a stable carbocation. So this is a 3-degree carbocation. Now the next step, this oxygen molecule attacks on this carbon. So if attacks, you will have, and let me lose one H plus here itself. So if I lose H plus, final product I will get the same thing, that is you have to derive. So things are simple. Are you getting or not? So there is no point to worry more. So you see you have a something of this kind of thing, and then you have this and this carbon. So how many carbon you will have? You see oxygen 1, 2, 3, 4, 5, 6, 7. So you should have 7. So you have basically this, and then you have one more. So let me write. So you should have 7. So slightly difficult. So let me make something like this. And here you have, so this is 2 carbon. Okay. So it's not looking like 2. So what can I do is, so I can make something like this. So I need 7, and 7 I need 1 oxygen here. This is okay. And now I need 7. So this is 1. And then I need here one more. So 1, 2, 3, 4, 5. And 6, 7. I need 2. So how can I do this one? Okay. So what I would have done is, let us rub this one. And if you're rubbing this one, and put this one here, and then put one more. Are you getting? So now it looks like 7. And here you have on this carbon, the carbon that is connected to oxygen, you have 2 methyl group also attached. So on this carbon you have 2 methyl group attached. So this is the final product. Simple. Now let us discuss the next problem. I think you have written this one. So let us discuss the next problem. This is again a problem of writing mechanism. So writing mechanism is a basically good thing. So let us say write down the mechanism for this reaction. So again, it's a writing mechanism kind of problem. So we have to write mechanism. So writing mechanism. So you have to write down the mechanism for the following reaction. So you see, what is the first thing? Whenever you have writing mechanism, first thing is you have to look the changes. What are the changes that is taking place? So you have to look for changes. That's good idea. So look for changes always. Look for changes. So you see, what are the changes that is taking place? You see, here you have this benzene ring. Here also you have benzene ring. And one cyclohexane ring. This oxygen has basically attached with this carbon. It looks like this oxygen has been attached with this carbon. That's why you will have two methyl group on this carbon that's here. Now things are very simple. Are you getting it? So what you will do? This H plus is attacks on this alkene, and you get a carbocation here, and this lone pair attacks on this carbocation. We have done. So let me write the same thing. I will do fast because I have already done this one. So this is the benzene ring, and there you have a cyclohexane ring, and here you have OH group. So things are easy this time. And then you have double bond O. Not double bond simply. Now if you attach with H plus, I said if you can attack a nucleophile here, alkene can act as a nucleophile in some reaction because it has a double bond. You can have a nucleophile that has acting a double bond. So you will have this, and then you have OH, and then you have this, and here you have CH3, and there is a plus charge. So it's a carbocation. Again, it's a tertiary carbocation. So 3 degree C plus. So this is a 3 degree carbocation. Now in the next step, you can use this lone pair to attack on this carbon. So this carbon that contains the positive charge. So attacking this oxygen. So what you will have? You will have to have this is 1, this is 2, this is 3, this is 4, this is 5, and oxygen is 6. So you have a 6-membered ring. So you can write. So you will have a 6-membered ring. So this is the benzene ring that is initially there, and again you have a 6-membered ring that was also there. And now I will have a 6-membered ring containing this, and at this position you have oxygen. So you will have this. Are you getting? And now at this position, so this carbon, basically this carbon that contains the oxygen, will have 2 methyl groups. So you will have 1 methyl group and another more methyl group. If you want, you can write something a better way. So it looks like beautiful. So you have to make something like this. So this is the final product. You can check yourself. This is the product you have to derive. Are you getting it? So you have a oxygen, carbon adjacent to the oxygen contains 2 methyl group. So you see, oh my god, I have oxygen, double 2 oxygen here. Okay, so I have done some mistake. So this carbon, okay, so basically this oxygen and this carbon contains 2 methyl group, not this carbon. So that's a mistake. So I have to attach this 2 methyl should not be here. This 2 methyl should be on this carbon. Are you getting it? Not simple. So I have to attach this 2 methyl group and this carbon. You see, this oxygen is attaching on this carbon. So this is a carbon number 1 and this is carbon number 2. So always better to write numbers. No confusion. 4, 5, 6. Oxygen is 6. Now see, carbon number 1 contains 2 methyl. We'll discuss next problem.